Good morning or good afternoon, depending upon where you are in the country, the world possibly. And welcome to this part two of our webinar series on rethinking managing production. Today, we're going to talk about material planning. The other webinars are scheduling, which we did yesterday. If you'd like to see or listen to the recording of that, happy to provide that to you. As well as costing, which will be held tomorrow. Some interesting topics. Cost, a little bit of a pitch on costing tomorrow. Costing actually talks more about, well, it does certainly discuss job costing, product costing. Really, the purpose of the conversation is to talk about the visibility of profitability and analyzing your potential for profitability in the company, and I'll leave it at that. So feel free to register for that tomorrow as well at this link. If or if you want the link, feel free to email me. My email's at the end of the session, and we can get that over to you as well. All right, well, let's get started on our topic of material planning today. So what's interesting to just think about and look at is kind of understand what sort of manufacturing you are in terms of managing materials. So are you making your products to stock where you have customers that essentially require immediate response? So you need to be building finished goods inventory. Are you more make to order where your customers really expect to wait some, fill in your sales lead time here, right, type of thing for the product to be produced, whether it's a few days, 6 to 8 weeks, months for your product. Assemble to order and configure to order, by the way, are sort of kind of specific versions of make to order, but certainly fall under the make to order umbrella as well. And then of course you have engineer to order, which is typically very complex, building one-offs or one-ofs, however you want to say that. Typically fairly complex machinery with thousands of material requirements on it, oftentimes a piece of capital equipment, which often borders on really even project manufacturing. And many manufacturers are, hybrids of this, right? So you might be some make to stock parts and mostly make to order parts. You might be, primarily engineer to order, but you also do some make to stock or make to order items. Sometimes engineer to order will be producing some spare parts as well for their products to have on hand as those are needed during maintenance reviews, that type of thing. But the material management needs, as you can tell, are different based on what type of manufacturer you are, right? So you have, and essentially it boils down to those three areas, right? The finished goods, whether you keep those in stock or not, pretty easy to answer. Raw materials, right? Whether you're keeping those in stock or not. But then there's this kind of gray area about sub-assemblies. Are we making sub-assemblies specifically for and in the same lot quantities of the parents that need them, whether that's a parent going into a finished good, or are we making sub-assemblies to stock as well in anticipation of their need for possibly multiple demands across multiple parents, right? And maybe even their own demand from sales orders from a spare parts standpoint. Okay, so so it can get complex, and then the other thing that's happening here is you have to you then it then becomes clear, what do I need to manage in terms of inventory, right? What I want to have enough parts, enough raw material on hand, right? So when I do get my make to order orders, I have that available, so I don't have to wait an X number of, you know, days or weeks or month lead time to get that in to start building, right? And then it goes up the chain, so to speak, right? How many sub-assemblies do I need to have in inventory at any one time? How many of my finished goods do I need to have in inventory at any one time? And sometimes the customer can answer that for you, right? Especially if you have many companies now, especially in the A&D market, will have specific obligations in terms of how much they need to keep in stock. I think they call it buffer inventory, right? But many times it's not so clear. You just know you need to have enough, but you're not sure, you know, how much is enough based on your customer's demand, okay, which is ever changing, I'm sure. And so it's pretty challenging. Now the building block of all of this, and you'll recognize this if you attended the scheduling webinar as well, is a work order, right? So once you're building something, or you decided you're going to build something, then you kind of put together this plan for that build, right? So in this case, my work order has, I'll bring up my other pointer here. My work order's got 4 operation steps. I'm building a certain end item, okay? And then over here on my first operation, I've got 1 raw material that I needed to start this series of operation steps. Now, this may be a raw material. I might have it in stock. I might have to purchase it. But this could also be a sub-assembly, right? Again, that might be in stock, or maybe I need to build this on its own work order somewhere else. Okay, then now I'm having to time these things. I've got another work order I've got to time the completion of to make sure it's going to be done, you know, in time for when I need to start this work order. Okay, so that's just one level, right? In that example, you might have many levels. You might have many sub-assemblies on that level, but you may also go down many levels through sub-assemblies as well. So it gets pretty complex. And here's a simple example where I've got, you know, kind of a top level job, and then I've got 3 sub jobs. And in this case, and what we can do is kind of help you tie these dependencies together. So in protected flow, what will, if you actually build the product this way, meaning you're actually building these 3 sub-assemblies, again, specifically for and in the same lot quantities needed for just this parent build, then we tie them together with these arrows showing, you know, these need to be done by the time I start my welding operation up here in the parent, okay? So in many and in most systems, ERP systems, you require 4 different work orders to do that, okay? Although some ERPs do support at least saying what it's linked up to, okay, whether it's a master sub job type of relationship or some sort of information that will give us an indication as to how to tie these together when they come in, okay? So you can manage them in different ways. These could literally be separate jobs, and simply they're tied together simply by, you know, this would then have 3 material requirements calling out each of the part numbers for these sub-assemblies, or you could have this hard link here where it's showing specifically I'm making this sub job, or these 3 sub jobs specifically for this parent, okay? And then again, this could get really complex. So now I'm going 4 or 5 or 6 levels deep. We've seen some companies' product structure go 10 or more levels deep. And again, some of these sub-assemblies may be on their own work orders. Some may be tied directly into this parent here. And then there may be other cases where I'm actually building these to stock, and instead of a work order here, I just have a material requirement saying I need some of these sub-assemblies for stock or from stock for this job, okay? So again, there's a lot of decisions you can make. There's a lot of different ways you can manufacture this, but again, knowing what these dependencies are, how those tie together, is very useful. Okay. but quite complex, right? So now take that whole situation and all those, trying to manage those dependencies and the common dates and what's going into what, and when each one needs to be started at every level. You know, you're multiplying that by the number of jobs you're managing, right? Which could be 50, it could be 500, could be thousands of jobs, right? So you can see how complex this whole material planning. So somebody is trying to figure out when you need, you know, all the various items and jobs on all different levels, and it's daunting. It's a daunting task. Okay. Every one of those work orders has a commitment to a customer order. If you're doing make to order, if you're doing make to stock, you've got an internal commitment for when you need that inventory replenished. And again, you could be both. Maybe you're doing both make to order and make to stock. And then every one of those work orders at least is going to need one raw material. Again, maybe it's a purchased item, stocked item, maybe it's a sub-assembly you're building. Either you have it in stock or you hope to have it in stock, or you're building it for that, specifically for that component. Okay. So it's, again, just talking to the complexity of it, right? So what are some common symptoms or common problems we see from all this complexity? Well, clearly, if you're having to keep, or you have a policy of keeping certain inventory on hand at whatever level, FGI, you know, finished goods, sub-assembly, or raw, then not having it on hand is a problem. And stockouts, that's what many companies see is I'm out of it, and now I've got rush jobs in the plant to try to replenish it. Or on the other, it always seems to be feast or famine, right? I've either got not enough of a certain item, or I've got way too much of a certain item. And there are reasons for that way too much type of situation, but which we may or may not discuss a bit here. Certainly knowing when to order more, right? Having that the visibility of the right time to either purchase more or to trigger production to make more is certainly challenging as well. Not to mention the quantities, right? Which is, you know, especially in purchasing, we know the more we buy, the better price we get, right? But that's often a reason we have too much of particular items. And then this flows over, you know, this concept flows over into production as well. Well, you know, we call those wow years, right? So while I have an order for 10 of these, I need to make 10 for another order, a parent, you know, let's make 50 more, right? So I've got a work order out there for 60, using up my capacity, which I may or may not need to be really doing. Okay, so that's one of the symptoms we see as well. And then you're clogging up WIP. If you were on scheduling yesterday, you know the 3 concepts to promote flow, and if you're not managing these order quantities well, then it's easy to get in trouble and violate those principles that help you manage flow well. Okay. And then finally, a lot of companies, if they're doing both make to stock and make to order orders, have trouble prioritizing those, right? You're at a work center, you've got 2 jobs sitting there. One has a customer due date on it. One has a due date that you've established from a replenishment standpoint. You know, really, which one is most important to be worked on next, right? So we're gonna give you a method and help you resolve that piece as well. Okay. So I think we've probably talked about this and the issues. You know, clearly some of the problems around specific sub-assemblies are just this idea of the dependencies and knowing not only right when this is going to start. So I may have a due date on this, or a date for replenishment. So I should be able to figure out when I need to start this operation. In which case I should know then when I need these by to be finished, and then I should have a good idea when I want to start these. And now I've got materials tied into these as well, right? So it's a question of knowing material requirement dates all across the board for my sub-assemblies and raw materials as well. Okay. And again, it just gets more and more complex the deeper and more complex your BOMs and routings go. Okay. So here's a customer of ours actually that makes industrial strength garbage disposal units, and indeed they make some of these items to stock, or actually they're a shared or common component that are used in, you know, not just this model but many different parents as well. And the same is true for maybe some children here, for some grandchildren also. So what they'll see in their ERP system are all the work orders that they have out there to build these various products. They're independent work orders in this case. They're not directly linked together, and that's kind of out of necessity because there's some commonality here. I'm going to be making more of these than just what is required for this unit. I'm going to be making them in anticipation there as well. Okay, so what we're going to be able to do for you is literally manage these due dates. So we can take the information that your ERP system has, and I was actually just on the phone with a client this morning where it was they had just a classic misalignment between sales and production. So their sales order delivery date said one thing, and their production order due dates, and based upon planning or whomever was creating the work orders, were setting due dates that were actually different even from the sales items. Okay. That aside, what we're going to do is we're going to take your orders, your work orders, bring them over, and then essentially turn this picture into something where they're synchronized. Okay, so that's really the issue, is synchronizing the demand of sub-assemblies with the supply, not knowing when they're due, not knowing when to start, not knowing how many to make. Okay, and also address the prioritization of we talked about make to stock and make to order, but also important to understand in the sub-assembly world as well. It's often a challenge for companies. So here's what we do when the jobs are literally linked together, right? Where I'm specifically making this sub-assembly specifically for this end item, and actually I'm making 3 sub-assemblies here. So if this will be recognizable to you if you were in the scheduling webinar yesterday, but we essentially create what's called an execution plan for each work order. Okay, so I'm going to have a custom execution plan for this work order when it comes over from the ERP, and then if it were separate, a custom execution plan for each of the sub-assemblies as well. Well, since they're linked together and we know they're tied, then we're going to synchronize those for you. So we're essentially going to create a multi-level custom execution plan for this structure that looks something like this. Okay, so you'll recognize this from scheduling also. So here's our due date for the end item. Here's the work that needs to be done, and we establish a time buffer. And again, I'll defer you to the scheduling to talk in more detail about these time buffers to protect my due date. But then each one of these sub-assemblies also has its specifically sized buffer or time protection on it, but they're all synchronized in time to make sure they're going to be done by the time I need them in this parent, in this case, the welding operation. Okay. So again, if this had sub-assemblies, which had sub-assemblies, etc., then this synchronization and this timing and of the various execution plans would be also aligned through all those different levels. Okay. All right, let's talk about if you are having to inventory items, if you do as a policy, again, whether it's from a customer service standpoint, you want to have items on stock, Maybe from a sub-assembly standpoint, you realize your lead time is going to be much shorter if you're able to carry the sub-assembly inventory so that they're readily available during the manufacturing process. So we're going to talk about the idea of a little bit of introducing a new approach to making sure that we have enough inventory, but never too much. Okay, and this approach uses a concept called demand-driven MRP, which has been around for about 10 years, actually. There was a couple of folks, Chad Smith and Carol Patak. Carol was actually the president of APIX during the 2000s for, I think, 4 or 5 years. And the two of them got together and essentially looked at traditional MRP, realizing that it really wasn't serving manufacturers' needs in the best way. And there's a number of reasons for that. There's a demand-driven MRP website. It's very educational focused type website. It's called the demanddriveninstitute.com. And you can go there and see a number of videos or read articles or blogs, and they compare traditional MRP against this particular approach. But the idea is pretty simple. What we do is we establish for every item that we're going to manage inventory for, we're going to have in stock, we establish what's called a planning buffer. So again, whether it's raw material, a subassembly, or finished item, that is, each SKU is going to get a planning buffer. And the planning buffer is a protection across your whole supply chain for that particular SKU, is the way you want to look at it, okay? So the way the buffer is configured is we talk initially about how much is a comfortable amount to have on hand at any time, okay? So kind of based upon your historical usage, based upon any forecast or future looking information you have, we'll talk about that and put in parameters to understand for this particular SKU or family of items, what does enough mean? Okay, how much would be enough? Okay, and then we look at how much you're going to use during the time it takes to get more, essentially. And that may mean a purchase order if this is a purchase part, or a work order if it's a manufactured part, right? And then on top of this, we add what's called a reasonable order quantity, okay? So that's typically how much we're going to order, what the quantity is going to be for that work order we put to the shop, or that order, the purchase order we send out to the vendor. Okay, so that may be dependent upon your vendor or your supplier. Maybe they won't accept a purchase order for less than they may have a minimum buy quantity, right? So we'd want to look at that as well. So we get to this point in the entire buffer that talks about enough. I've got enough in my supply chain buffer for this item, okay? And then very simply, what we do is we give you a view in the software that shows for every item you're inventorying where it is in its planning buffer. And we call that the net flow position. So it gives you a marker. So here I've highlighted this particular item, which is in the yellow zone, okay? And I can see over here, because I have this highlighted, then it brings up the planning buffer for that item. Now here's my net flow position. What does that mean? Well, the net flow position is my on-hand quantity plus what I have on order minus my demand, my qualified demand. So in this case, probably sales orders, to calculate out on hand plus on order minus demand equals my net flow position of a little over 1,000. So here I am sitting at a little bit over 1,000 on my planning buffer. So this tells me if I'm below top of yellow, very simply, all I need to do is issue a replenishment order to get me back up to top of green, okay? And that's all the software is doing, is showing me, Mark, you need some replenishment here. You need to replenish this suggested replenishment order for this quantity, 788, which is going to get me up to the top of green, okay? Now what's neat about this is if for parts that are in the green, I don't need to worry. Why even bother looking at them, right? I just want to manage the exceptions, just those that need attention. So I'm going to look at my yellow and red parts and do those, okay? Now, the neat part about this concept and why it's quite different than traditional MRP, there are a number of reasons actually, but in particular why it's different than, say, order points or safety stock, is that this buffer is dynamic. It actually flexes like a shock absorber. So as your actual usage changes, and these buffers are literally sized on either actual usage or forecasted usage, typically both, usually more heavily weighed on the actual usage, okay? So the idea is if my actual usage is at 10, in this case a daily usage, could be weekly or monthly, is 10, then my planning buffer size is going to look like this. If my usage spikes, in this case goes up to 15, then my buffer is going to be automatically and dynamically sized and adjusted for that new demand level, okay? So where I was previously in the green zone would no longer be, it'd probably be in the yellow zone, prompting me to place a replenishment order to get me back up to top of green, okay? Similarly, if usage drops, in this case goes down to 5, then my planning buffer is going to be resized accordingly. And where I was previously, prompting me to place an order perhaps, I would be no longer. And here I'd either just sit and wait it out or even de-expedite an existing order that I might have out there. Okay. So very powerful method of being able to manage inventory. So the idea here is that you always have enough. The goal with demand-driven MRP is that you always have enough inventory on hand, really not even inventory on hand. It's that's kind of the net effect of managing that you always have enough in your supply chain buffer, okay? That's really the big difference. And then as a result, you will always have a comfortable amount on hand, okay, with much fewer stock outs. But the other side to this equation also is it's controlling that you don't have too much. And this is what we find oftentimes as well with that, whether that, elephant within the snake type of thing, people buying too much for certain lot sizing, pricing quantities, which may be fine, but let's look at it and understand, what we're doing by doing that, tying up cash potentially, okay? So that's the goal of demand-driven MRP, and that's one of the big differences between traditional MRP. If you look at the design of traditional MRP, it's actually to get to zero inventory, right? In MRP, you want to have your supply perfectly matching your demand. Well, you don't really want to get to zero inventory, right? You always want to have enough inventory, and that's what demand-driven MRP focuses more on. Okay. What's neat about this is that PFM can now tie together the kind of material planning and the scheduling together. And let me talk about what I mean by that. So when DDMRP suggests a work order, and it says generates here, it's going to generate a suggestion for a work order, right? And then you're going to create that work order probably in your ERP, right, which will then come over to PFM. But when it creates it or suggests it, it will also specify a due date that's appropriate to keep you from running out during the time it takes to make more, right? So it starts out as a relative commitment. So we have this feature called elastic work order dates, which actually keeps these work order dates aligned with your actual consumption. In other words, if we see that if PFM sees that your actual consumption is increasing, much like your inventory buffer or your planning buffer is increasing, then this is going to dynamically adjust that due date, realigning its priority. So if consumption goes up, it's going to pull in that due date automatically to make sure you get that resupply sooner. Okay. On the other hand, if it drops, then it's going to push that due date out automatically. Okay. And so this happens not only if you're tracking actual consumption of inventory, but it can also work against your sales orders and changes in sales order dates. Okay. Which is actually what I was talking about with the client before the webinar today. Was their sales orders were misaligned with their production orders. So we can say, just bring that information in, and we'll run the elastic work order due dates feature, and that's going to align your true demand on the sales orders against what you're producing in production as well, and always keep that aligned. Okay. So what happens if your sub-assemblies are separate work orders in your ERP, and somebody invariably, and depending upon the size of the company, somebody's managing all the due dates on these different work orders to supply their upper level jobs or work orders, right? Sometimes it's 2 or more people, depending upon the size of the company, right? What we'll do is we'll take this information from your ERP in whatever due dates exist on the work orders now, and run through, it's essentially the elastic work order due dates feature as well. And that's going to turn this picture into that, where each level is perfectly synchronized to make sure whatever quantity is needed first in whatever parent is going to be timed and synchronized to make sure that's going to happen. Okay, so now you're not having to worry, you're not having to manage all those due dates across all those levels. And every level is buffered to make sure there's going to be sufficient time, an allowance for variability to make sure those are going to get done for whatever level that needs them. Okay. So by keeping the due dates of make to stock orders up to date with the actual usage, okay, like we're saying with elastic work order due dates, this is always protecting your promise of not stocking out, right, in a make to stock environment. At the same time, you have due dates for make to order parts, right, that are based on a commitment you've made to the customer, and those are being protected as well with a time buffer. Okay, so the due dates are both generating the priority against which in the scheduling webinar you'll recognize as the threat level, right? So the threat level on a make to stock order is going to be relative to the threat level on a make to order, and that so now we're able to answer which one is more important to work on. Am I more in danger of being stocked out, or am I more in danger of missing this due date to my customer? And that's what this priority threat level mechanism will do. Okay, so whenever you look at a priority list in PFM, that you're always working on that work order, whether it's make to stock or make to order, that can least afford to wait any longer. Okay, that's the right job to be working on. Okay, I'm actually going to pop out into the software for a moment. I'm going to turn my screen off, and I'm just going to show you a view that I had up earlier that I wanted to share. So this is a feature in the software whereby I can see, let me show my screen here. So here I'm showing just about a half a dozen work orders, okay? And these work orders actually are quite complex. They're multi-level work order, in fact. In fact, if I open one of these up, you'll see This is quite a complex work order, right? In fact, I can go into this mode and kind of scroll down, or I could zoom in or out. Kind of see it that way. Back up. So I can see I've got a lot of different sub-assemblies, and the sub-assemblies have sub-assemblies, and they also have raw materials on them, okay? So quite a complex project job. Now, which I could also see in a text mode. Okay, so if I want to come through here, see that information like that, all the sub-assemblies as well, okay? I've got about a half a dozen of these in this database. So if I come back over here and work order status board, then that was that swing arm display right here. So here's the beginning of the job. This is when I either should have started it, right, or need to start it. And I'm going to finish the whole job out here. Okay, so it looks like I've got probably 3 weeks or so of work that needs to be done. Yep, the predicted start date is May 27th, and the predicted finish date is June 22nd. I think today in this database is like May, the first part of May. Okay, so it's about a month-long job. Now, I can also see, scroll back over, because this is quite a complex and has a lot of dependencies, I can highlight this and go into what we call the subframes. So now I'm seeing the same picture, only here if I scroll over, here's where I finish that last packing operation. I've got a lengthy packing and assembly operation that all these different sub-assemblies need to come into. Okay, so I see the timing of all those across all levels and when they're predicted to finish. So here's, I've got it's actually going to start back here. Okay, so this is the level of visibility I can have, and this is on a project where everything is linked. But the neat part is, even if these were all separate jobs, the program will do the same thing and assume the links based upon either soft or hard allocations that have been made in the system. Okay, and we'll actually show, if I come in way over here, it would then actually show all the different levels. There'd be another field here that would show every level of every work order. Okay. With that, I'm going to open it up for questions, and certainly feel free to reach out to me on my email or to our website for more information. But if you do have any questions on what we covered today, happy to answer them. Let me bring up my question window here. See, I don't see any momentarily. Feel free to type something in there or in the chat. And otherwise, if there are no questions, then feel free to contact me directly if you have any after the webinar. Nope, don't see any coming through. Well, thanks everyone for joining, and hope you have a great rest of your week. Thanks all. Bye.